SpaceX is all set to do something spectacular with the launch pad, and we can all see the ultra-modern renovation that has been done here. Now, the new version of the super heavy booster, Booster 9, has been rolled out to the launch pad, and surely it will soon be ready to dominate space. The new-fashioned launch pad is designed to stand out and beat what we've ever set our eyes on in other space companies. You know, the last Starship launch ended in a heartbreaking blast, though that was a step ahead to extract necessary information for a concrete modification of the launch pad, and since it actually suffered in the hands of the Booster 7 rocket. So, what are the tectonic innovations being done on the launch pad, and would it survive Booster 9 thunderous blast? Also, what exquisite changes has been done on the Booster 9 rocket to prepare it for its next victorious sailing through the clouds in space? Let's explore all these and more in today's episode of Tech Spacex. Starship is the tallest, biggest, intimidating, and most powerful rocket ever built, capable of generating nearly 17 million pounds of thrust upon liftoff. And all that power is undoubtedly enough to cause some major destruction near the launch pad. The last Starship launch was a destructive one that tells how much the booster was on a mission to crumble the launch pad. Other pieces of equipment, including storage tanks near the launch pad, also suffered damage, which has raised questions about when Starship may be able to attempt another launch to space. Booster 9 majestically arrived at the orbital launch site ahead of a static fire test, which will also be used to validate the authenticity of repairs and upgrades of Starship's launch pad. That rollout is a key milestone in the launching process ahead of the second flight of the world's most influential rocket. So, SpaceX will soon start the launch campaign for Starship's third flight, while upgrades at Starbase production site continue forward in full swing. But there will be a strenuous process that is installing the water-cooled steel plate system that will be used starting on the next flight of Starship. SpaceX was careless about installing this system during the last launch. Perhaps they thought nothing critical would happen, but the explosion shocked us all. And now, the right measures are being prioritized. The manifolds that provide water to the water deluge system were erected immediately after the main central plate on the launch mount, which had been installed a few weeks before. A central plate with 6 sides, 3 of which are connected to these manifolds, and the remaining 3 of which are closed off, makes up the entire water-cooled steel plate system. On the south and west edges of the central plate beneath the orbital launch mount OLM are where these 3 manifolds are situated. To connect these to the ground storage tanks that are situated on the opposite side of the Starship launch tower, pipelines were also laid down immediately after these were placed. So, you now know the use of the tank besides the launch mount. It's not for fancy. There are 2 main water pipes that lead to the 3 manifolds. One of them splits in 2 near the OLM and supplies water to 2 of the manifolds, whereas the other pipe supplies water to the remainder. Here's where water suppression system crew execute their welding skills. Pad crew welders have been working non-stop on this system, welding, grinding, and adjusting all of the hardware for a proper installation of the system, and placing other components at the right place. Almost all of the launch pad systems that were fixed and modified were tested throughout the modification. On July 13th, one of the initial tests took place when the pressure and water pipelines that are a part of the new water ground tanks were flushed. Up to 7 tests of the OLM Raptor quick disconnects, which aid in the testing of the outer 20 engines of Super Heavy, were conducted the next day, on July 14th. More testing happened the next day, but this time, it was about the orbital tank farm. After a few hours, the test was abandoned by the workers, after there was indications that a system about the tank actually failed. On July 17th, when the first water began to flow through the pipes and up to the steel plate beneath the OLM, the test that perhaps attracted the greatest attention took place. A little trickle of water built up and spilled over the sides of the plate as this first began under low pressure. It turns out to be a wonderful sight to behold. The test of this system culminated in a burst of water shot upward under the OLM after a progressive increase in pressure. This was thought to be simply a partial test, possibly using one of the system's 3 manifolds and at reduced pressure. The necessity for a static fire test won't arise until after Booster 9 rolls out to the launch site, therefore it's highly possible that a full-flow and full-scale test won't be conducted until then. In the evening of July 18th, a second round of launch pad tests took place, and there was noticeable venting emanating from the orbital tank farm. As shown by the presence of the now famous OLM and launch tower vents connected to the system, ground cryogenic conduits were also ejected out. In a quest to prepare for the forthcoming Booster 9 static fire test campaign, even the launchpad FireX system was put to the test during this campaign by being turned on for a few seconds. The static fire test campaign for Booster 9 might start as early as expected. Early on July 18th, the vehicle was relocated from the Mega Bay to the Rocket Garden of the Starbase, and later pushed down to Highway 4 to give a better look at the improvements, which include a set of cylindrical metal tanks fitted where the smaller set of aerodynamic chins once stood. All of the chins on Booster 9 now appear to be the same size, because of its body modification that left many things covered. Of course, there may be more to these tanks. However, Elon had mentioned on a recent Twitter space that the water tanks might be for additional consumable storage for the booster or storage of purifying gases for the engine bay to prevent fires. Spacex is hoping to execute a full engine static fire test before the end of the month now that Booster 9 is on the launch pad, and that will be the return of a Starship with everything it needs in mid-August, followed by a launch by the middle of the month, and all-cost Spacex will make sure all these are possible. However, there are factors that need to work together for the Starship to lift off, and they are the launch pad, weather, and vehicle hardware must all work together for this to be successful. Additionally, the FAA must give Spacex permission to fly before it can take off. This will entail updating the launch license for the rocket to incorporate the second flight as well as any more potential alterations to the flight profile, if they turned out to be necessary, and recertifying Starship's flight termination system. Again, more on what's going on at Starbase. After being released, Booster 9 was spotted with a fresh set of FTS charges that are now in their numbers. The original FTS charges, which are still there, are at least 2 rings above the common dome weld line, at the bottom of the liquid methane tank. In the event that this mechanism is set up and activated during flight, Booster 9 will lose all structural stability, which will effectively bring the flight to an end. If SpaceX succeeds in launching Starship the second time in August, the company may launch 2 more of its extra-large rockets before the end of 2023. According to sources, SpaceX may aim for 8 to 10 Starship missions between now and 2024, which would include test flights for Starlink and on-orbit refueling as well as the activation of Launch Complex 39A in Florida. The production facility at Starbase is just as busy as the launch pad. Only a single more floor needs to be added to the new Mega Bay building for the main structure to be finished. For the production site's additional office space, a roof section may also be built. In the high bay with a single reinforced ring on top makes up this test object, designated S24.2 on its label. This ring has many pipes protruding from the sides and an oval dome affixed to it. This device appears to be a component of the test setup for the ship's cargo bay section's structural evaluation. At SpaceX's Massey test facility, the nose-cone structural test stand is currently being adapted to accommodate this structural testing, before employing the structure and mechanism to launch Starlink satellites. Also, the Booster 10 is not left out of the modification breakthrough. It was seen at Massey, standing tall and ready to begin its cryogenic proof test campaign. This booster will likely undergo multiple tests for more weeks and head back to the production site where it'll receive the static fire test on its engines. At this point, we wrap it up in today's video. How long will it take SpaceX to start the next Starship test flight?